for the problem.
Let me just write the question just once, just for the sake of doing it. Just yeah. So let's say that we draw a certain number of lines. This is one line. There is another line. There is a third line, and so on. Okay, and our claim is we can color it perfectly using.
So there were 11 parts.
2 colors. Yeah, I mean, see, 11 was in the figure that I drew. But the point is, no matter how many lines you draw, you can always color it perfectly with 2 colors.
Oh, you're saying that how many ever lines you draw, you can color it with 2 colors.
Yes. So you draw how many ever lines you want. See, that's a huge claim, right? I mean, you draw 153,476 lines, and you can still color it with 2 colors perfectly, right? That's what we are talking about. All right. So I'm just keeping it as, okay, let me draw maybe one more. Maybe I'll listen to Anahita and then I'll see if I want to change this. Okay. Anahita, go ahead.
Yes, sir. So I couldn't just write a proper proof mathematically, but I just logically deduced some things which might be helpful in writing proof. So as we know that any shape, now let's say a rectangle that is in front of us, if we just see that we have drawn only one line, so that one line will divide it into 2 equal parts. Similarly, if we draw any line, so further and further, as you just drew 4 lines, so that lines were intentionally dividing the previously made shapes due to previous lines into two parts. And as they were getting divided into 2 parts, or the shapes when a line is passed through them share only one common side, obviously, like logically we can assume, or we can see that it is happening every time they are having even number of squares.
Let's go a little slow. So you are saying if you draw the third line like this, okay, what is happening when we draw the third line?
When we are drawing the third line, we are technically dividing at least a shape or 2 shapes into more parts. And basically what we are doing is we are dividing the parts into 2 parts. So it's even number of parts. So we can
so something like this. This line is passing through 1, 2, 3 regions.
Yes.
Right? And each of those regions is divided into 2 parts further.
Yes, and that is happening with every line, and therefore we can see that we can just introduce alternate colors for every region, and then it will be possible for any number of lines.
Okay, let's just try out a few. So suppose I draw the second line here, then this region is divided into 2 parts.
Yes.
Right? If we take another case, let's say that there is one line here, this is the second line, and we draw the third line that is, say, passing through this point of intersection, then also there was one region that was divided into 2 parts, there is another region that is divided into 2 parts. So whichever regions it passes through, it will divide that region into 2 parts further. That's what you are saying, if I understand correctly.
Yes, and that's what is happening every time we just draw a line, and therefore, like it's it's obvious after that to say that yes, we can now fill that region with 2 colors, as there are even number of places, and we can just do alternate.
Okay, so wait. So now you draw this line, and then what do you mean by alternate color? To do it alternate colors, I alternate regions or something. I didn't get that part.
Okay, sir. So it's even number of regions. So let's say we have drawn
Not
a
yet.
circle.
See, this part makes it odd. The blue star, you see.
Yes. Okay.
Right, and here also this makes it odd, and in the earlier drawing that we had drawn, we had 11 parts, so that's also odd.
Yes, sir. But actually, what I want to say is that whenever a line is passing through that whole shape, it is necessarily dividing that shape into two parts, which is making, like, let's say even if there are odd number of parts, it is adding up two to it, and then we can just maintain that sequence, what however it might be, and
Okay.
that is still
So
working out.
are you saying something like this? For example, when you draw that red line here, now you are dividing the entire plane into two parts. One is this green part and one is the blue part. Is that what you are saying?
Yes, that's what I want to say.
Okay, okay. Oh, I see what you're saying. So what you're saying is, if I draw this new line, sorry, if I draw that new line, it is going to divide that. All right. So let's try it here. Let's try it here. Color, maybe take this. Okay. So what she is saying is, let's take a line. Let's say this is my line, and by adding this new line, this is my new line. It is dividing the entire thing into two parts. This is left side, this is right side, so to say. Right. So whatever is there towards this side, let me call this as regions on side A. This side is regions on side B. Now what do we do, Anahita?
Yes, so we can now see that. Can I just annotate for a
Please,
minute?
go ahead.
Yes, so now we can see that. Oh, sorry.
That's okay.
Yes, so now we can see that as you have drawn this line, this part has been divided into two equal parts.
Two
Not
parts.
equal, I mean two parts. Yeah.
Yeah.
Then this is being divided into two parts. This is being divided into two parts. And if we see as a whole, the whole rectangle is divided, as you said, into A and B parts.
Yes.
So that's what I was saying. After that, if we can deduce some logic after that, and if we say that that will happen, go on happening, and that will, like,
So
it will
what
be
is the advantage of
process.
dividing that into two parts? What's the advantage?
So now we can now if we have divided that, just a second. So we will get to color this part same, this part same, and say this part in red color, and then we will be able to color the remaining parts in, say, blue color. So that would be the part, the, like, that's what I want to say.
Okay. So if I understand correctly, you tried out something and then you added one new line and then you tried recoloring and it was working, and probably you tried it for some cases, right?
Yes, I did
it. Okay. Good, very good, Anahita. That's a very good start. Okay. Samyak.
Yes, sir. The advantage of adding that line is that now we have k plus 1 amount of lines. So something we can deduce something from that. Now we have one more line.
So you're saying this is the k plus 1th line, and before this we had k number of lines. Okay. Kavin?
I don't think we can do it with coloring two blocks.
Why not? You have a counter example? You are on mute.
Oh, so if we color one block, which is, I'll just under A. So let us, if we color this block, it will, it has 1, 2, 3, 4 sides. And so this total drawing will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Sorry, we can't
11.
see where you are counting what you're drawing.
Okay. I'm just counting the number of lines. So if we color one block, it is only covering 4 lines maximum. It can only cover 4 lines in this drawing. But the total number of things is more than 8. The total number of lines, 8. 1, 1, this will be 1, this will be 2, this will be 3, this will be 4, 5, 6, and so on. It will be more than 8. So with two things, we want coloring 2 blocks, we won't be able to separate everything.
No, you show me one example where it won't work. If you have found one.
I'll just try and I'll inform.
Yeah. All right. So let's continue from where Anahita and Samyak had left. So I'm just going to try to recollect what so far what we have done. What we did was we did something like this, right? Let me clear the annotations. Yes. The claim was you can do a perfect coloring with 2 colors. Proof, we said we will prove this using mathematical induction. We will do induction on n, where n is the number of lines. Induction hypothesis is that we can do a perfect coloring with 2 colors for k lines. One thing that it did not mention over there is what is k. So where k is some arbitrary but particular value or particular, say, integer. Okay, can somebody explain what this means, what this fancy wordings mean? Arbitrary but particular. Arham.
Sir, it means that the adversary can choose any number, but then after choosing that number, he should not change it. It should be fixed, a particular thing.
Right. So arbitrary is, it means you have a choice to choose anything. So the adversary is giving any value, but once we have proved it for that, then he cannot say, oh, you proved it for this, now try for this, or you prove it for this number, because then it will be a never ending story. So we can choose some arbitrary, but once it has chosen, it's a particular integer. Okay, and then we go to this base case. So base case, we show for n equals 1 and it's verified for one line. The goal is to prove that we can do a perfect coloring with 2 colors for k plus 1 lines, right? And this is where we are. So I'll continue from here. Kavin, is it that you have found a counter example?
2 colors means we are coloring 2 blocks, or we are supposed to use 2 colors.
We cannot use more than 2 colors, and we need to color every region
with those 2 colors,
such that the neighboring regions will not have the same color.
So I thought 2 colors means we are only coloring, like if there are 10 blocks, we have to use 2. We have to only color 2 blocks and make no such region has common border.
No. Is it clear to everybody? We are suppose we have X number of regions. We are using 2 colors to color all the regions, but such that adjacent regions will have different colors. Yes, Kavi? Okay. Not Kavin, Kavi.
Excuse me, sir. Sir, but in the base case 1, the
Yeah.
opposite sides has different colors, right?
Yeah. So what is the problem? The
So
problem say
base case 1, it is both adjacent and opposite.
see, what does it say? Adjacent cells should not have the same color. Are adjacent cells having the same color? Adjacent regions having the same color? Are adjacent
No, the
cells having
opposite
the same?
sides has different colors.
No, but we are not, the problem is not about opposite or anything. No? The problem is adjacent sides should not have the same color.
Yes, sir. Adjacent side didn't have same color.
They don't have. So that's about it. Somebody can think about opposite, somebody can think about something else, but that is not what we are talking. We are talking about if you draw any number of lines, the adjacent regions should not have the same color.
Yes, at first I thought it as n equals 2 because when I first divided the plane into half, I thought it was adjacent. The adjacent side has different colors.
Yeah, but then here we are using two colors, no, red and blue, let us say.
Okay.
Okay. All right. So let me go back to this particular coloring now in this rectangle. Okay. Let's say this was our line number 1, this was line number 2, this is line number 3, and we have a line number 4. And now we have the 5th line. So in this case, let us say that our K was 4. So our K plus 1th line is the 5th line. Okay. I hope everybody is looking on the screen. I can see people working. Just take a pause, look here. Now with this line, like Anahita was saying, we have divided the plane into two parts, A and B. So what we are saying is, if you look at whatever is there on the right side or to the B side, keep them as it is. You know. Now I go to the left side or the A side and I say wherever there is a yellow, you put white, and wherever there was a white, you put yellow. That means you swap. Now there is a white here, so you put a yellow, right? Suppose you do this. Suppose you do this. Let's see what will happen. This was yellow, so let me just keep it as it is. This is yellow, and this will be white. Now, is the coloring perfect?
Yes.
It is perfect, right? Nothing has changed. Nothing has changed. So maybe somebody will say, well, maybe you did something to your advantage. Let's do one thing. Let us keep the A side as it is, and let's go to the B side. Again, wherever there is a yellow, you put white. And wherever there is white, you put yellow. So I'll do this rubbing thing. Okay. So now wherever there is yellow, I'm going to put yellow. So this is yellow, this is yellow, this is yellow, this is yellow. Right. And oops, this thing is white. So my question is, is it still a perfect coloring?
Yes.
Yes, sir.
It is, right? So what's the idea that we are using? We are saying, look, if you have a plane with k number of lines, and let us say you have the k plus 1th line. Let's say this is my k plus 1th line. Okay, k plus 1th line. By induction hypothesis, we know that before the k plus 1th line existed, a perfect coloring was possible. Can we say this? See, you are the adversary. You say, huh? How do you know that? Let's assume. Let's just assume that that was possible. We say, okay. Now we say, put that k plus 1th line where you want to put. Okay. So the adversary tries to, put it in the most difficult place according to him or her. So this is where the adversary puts the k plus 1th line. Okay, k plus 1th line. Then what we tell the adversary is, look, now if you listen carefully to what our friend Anahita said, the plane is divided into two parts, and this part we call it as A part, and this part we call it as B. Now you keep the coloring on A as it is, and you swap the colors on B. So what is going to happen is, this region had yellow, suppose. This region also had yellow, before the k plus 1th line was introduced. Okay. This region also had yellow before the k plus 1th line was introduced. So when we have this new line, right, k plus 1th line, what was yellow is now white, right? And you had a white here. So this becomes yellow, a small portion here yellow. And then you had a yellow here. So this is white. And then you had a white here. So this becomes yellow. And then you had a yellow. So this becomes white. You're just going along the line, along that line, right? You're just going along that particular line, and we are just swapping those colors. So when you swap those colors along that line, on one side you have a different color, on the other side you have a different color. And a perfect coloring, so if you take on A side, there is a perfect coloring. On B side also there is a perfect coloring. The problem is when you draw that line and if you look at it completely as one picture, then does the region A plus B have a perfect coloring? How do we fix that? We just do this swapping business. To give you a simpler example, let's take this is just an example for representation. Okay, this is, let's say that we have something like a chessboard. Okay, chessboard. Let's say we have this chessboard thing and we are coloring it. This is yellow, 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 right? This is chessboard. Now we introduce this line. So what we are saying is, towards the A side, this side, there is a perfect coloring. That means if you are only looking at this part, there is a perfect coloring, no problem. If you are only looking at the right side, there is a perfect coloring, no problem. But now when we look at this entire thing, the perfect coloring is not happening, because along this line, you see, along this new line, you are having these two regions, these two regions, these two regions, these two, they are adjacent and they have the same color. How do we fix it? You swap. Put this color here, you put this color here. You put this here, you put this here. Put this one here, you put this one here. And you keep on doing it. Keep on doing it. And because we are only swapping and we are not changing the colors of some regions to something else, but we are changing all. So there will be a perfect coloring on the complete plane. Want to take a pause here and see how many of you have understood. So if you are not clear with this, you can send me a message either directly, as a private chat, or you can do a raise hand and ask me if you haven't followed, so that I know how many of you followed, how many of you did not follow.
Sir, I have a doubt.
Go ahead.
Sir, in this view, the blue line is the new line which you have drawn for k plus
Yes.
1.
Yes.
And if we draw, then we divide the remaining squares into alternate or something
Yes.
like that.
Yes.
Okay,
Yes.
okay.
Right. So I got one question in the chat. Arham, I'll come to you in a moment. Sir, this we are demonstrating for each case. How can this be proved true for all cases when we switch colors? So that's a very, very good question. I'm just using this to demonstrate of what happens when the swapping, thing happens over there. Okay, I'm just using that to demonstrate that particular part. I'm not saying that it works here, therefore it will work everywhere. I'm just trying to see, okay, are you convinced with this? If you are convinced with this, try to extend that idea and see what will happen if you are having you know, if you are having any graph, okay.
Yes,
I have a couple of more comments. I'll just try to read that. Meanwhile, you can think about it. Okay. Is everybody okay with this? Parul, are you okay? Convinced? Okay. Shriya,
sir.
Arham. Yes, Samyak.
Sir, we have to add another hypothesis, right? That
What?
when we invert the grid, it inherits its perfect coloring. That's not
Ah,
evident, is it?
right. So that part is actually evident. I mean, that may not seem to be evident, but logically that is. So what I mean by that is somebody who is reading the proof cannot refute to that particular argument. And the idea is as simple as, I mean, it's not simple, but it's like this. Okay, let me do this. Let me give a different argument, and I think this argument might be a better argument. This is my k plus 1th line. Okay, this is my k plus 1th line, and I'm writing this. Induction on n, induction hypothesis same as what we wrote earlier, base case is the same as what we wrote earlier. Induction step, what I'm writing over here is, consider a plane with k plus 1 lines. Okay, not considering k lines, I'm saying k plus 1 lines. So who is giving me this plane with k plus 1 lines?
The adversary.
Adversary. Right? So nobody is cheating here. So adversary gives you a plane with k plus 1 lines. Who is placing the lines on the plane?
The adversary.
The adversary.
Adversary, right? So we are not touching it. We are saying you put it there, and I'm just going to argue with you. So consider a plane with k plus 1 lines. The adversary gives you this. Now you ask the adversary to remove the k plus 1th line. Okay. So the adversary says, okay, I have this. This is 1, this is 2, and say this is 3, and let's say this is k. So this is what it will look like. The adversary removes the k plus 1th line. And we say, by induction hypothesis, this can be now perfectly colored with 2 colors. This can now be perfectly colored with 2 colors. Is this okay? Any problem? Am I cheating?
No.
So you're
No.
not cheating,
If
but
it's,
after you
repeat
remove the
some,
line,
remove the line.
One second, Parul, complete it.
yeah, after you remove the line, the coloring will differ, right? Because one line has gone, so certain parts have disappeared.
So I haven't spoken about the coloring yet. I'm saying you just give me a plane with k plus 1 lines. Remove the k plus 1th line. Whatever is left, it can be perfectly colored. Right? All right. So everybody is good with this. So I say, now do the coloring. Okay. So the adversary does that perfect coloring. Or let's say that, adversary doesn't know how to color. So we don't worry about it. Okay. So it can be perfectly colored. Now, remember, we are not even coloring it. Okay. We are not even coloring. Now what we are saying is, you see, the k plus 1th line is something like this. So we tell the adversary, we ask the adversary to place the k plus 1th line back. Okay, to place the k plus 1th line back. And then we tell them, now, okay, sorry, maybe we'll have to, yeah. So now we tell the adversary that, look, this could have been colored with perfectly colored when you had this, what do you call that, K lines, it could have been perfectly colored. So we are saying whatever color existed here, let me put dots and crosses, no, it would have been something like this, and for the rest of the plane, right? So on one side you swap and the other side you don't swap. So if you swap on one side, what is happening is it would have been something like this, right? It would have been something like this and some other coloring over here and some other coloring. Suppose this was a bigger plane, some other coloring over here. We are saying on one side you swap the colors, on the other side you don't swap. Now let us take one part. Suppose you take only this part, okay? If this can be perfectly colored, will swapping change the perfect coloring, or can it still be perfectly colored? It's something like if you take a chessboard and if you color all the black cells white and white cells black, will it still look like a chessboard? It is still colored perfectly with two colors, right? So what we are saying is, by swapping, the perfect coloring
Chessboard
on
will
that
become
side does not change. Vihan?
Yeah, but the chessboard will become different, right?
Yeah, so but still it is okay. So ignore that question whether the chessboard will look like a chessboard. Consider the question, will the perfect coloring still exist?
Yeah.
That will still exist, right? That's what we are saying about the other side also. You don't swap. And there was a perfect coloring earlier, so now the perfect coloring will still exist over there. When
Right,
we
so the
swap,
perfect coloring.
go ahead, who is that? Urvi?
So I think the perfect coloring would remain on the other side with each other's edges because we have just swapped the colors. And for the edges with the other side, you would have a perfect coloring too, because earlier they were the same color and now they would be the opposite.
Do you see that, Urvi? Do you see that?
Yeah,
When
yeah.
we do the swapping
Yeah,
on the
because there are
border,
only two types of edges that it can have. It can be either with the other side edges, or it can be with the same side edge shared with the region in the same side.
Okay, few hands are raised. Let me just take maybe Samyak question or comment.
No, sir, I just asked this one. Yeah, but
Okay.
still the adversary would have to agree that when you invert the colors, it will maintain its perfect coloring. Like only
Right.
for
So,
the right side of the grid, not the whole thing.
yes. So that is something that that we cannot convince other than, just ask him or her to think logically.
Okay,
There
sir.
is no other. So that we can consider something like a common knowledge. Smrinil?
Yes, sir. Sorry, I forgot to load. But sir, even if we change the colors, the chessboard, it will become a water image of the other one. If we rotate it, it will become the same thing, right?
Yes, yes. So I'm not worried about whether it will look same or different. What I'm worried about is, will a perfect coloring exist?
Yes, sir. Okay, sir.
It will exist. That's all. Because my problem is I want to show that a perfect coloring will exist. Anahita?
Yes, sir. So I did not get why did we just first added the k plus, like we, like first one is just k lines, but then we ask the adversary to add a k plus 1th line and give the plane to us. Then we colored it and it got colored perfectly. And we told the adversary to remove the k plus 1 line. So why did we do that? I did not really get.
Right.
To just
So
prove that it is happening.
no. So this, whenever you do problems with vertices, edges, problems in graph theory, and all that. I mean, in case you aren't introduced to graph theory, don't worry about it. You'll learn it sometime soon. So in those areas, when we are saying you add a line, there might be somebody who's saying, well, if I add a line, how do I add it? Should I add it like this? Should I add it like that? So it's always better to ask them to remove a line and then place it where it was earlier, so that the adversary does not interfere a lot of times in your business. Now, in this problem, it may not be a big deal. In some problems where you have, let's say, you are having, this is what we call, let's say, this is a friendship graph. Okay, this is a friendship graph, and this is A, this is B, this is let's say this is A, this is B, this is C, this is D. It means B is friends with A, B is friends with C, B is friends with D. And if B is friend with A is also friend with B. Okay, and A does not know C, A does not know, or A is not friends with C, A is not friend with D, C is not friend with D. That is what we can infer from here. And if you are trying to prove something like this, if you say that you add a vertex or bring in a vertex E, maybe that new person knows 2 people, or maybe that person knows 3 people. So when we are saying you add this new person, we don't know how many new friendships or how many new edges he or she is bringing into the graph. But instead, if you say, consider a graph of 5 people with certain number of connections between them, somebody knows somebody, somebody does not know somebody, and so on. So if we consider that, and then we say remove the last person, okay, then whatever that person, whatever connection was there on that person, that gets removed, and you prove it, and you say that now you place it back, and I will show that it still works. So it's always better to say that you give a graph of k plus 1, you remove an edge, now you place it back, you remove a line, and then you place it back. And to understand the subtlety of this argument, you will have to do a few examples, and that is where you can see the power of this argument. Anahita, you have a question?
No, sir, it was me. I got it.
Okay. Shiva?
Yes, sir. Sir, induction hypothesis is something that we ask the adversary to assume to be true, right?
No. Induction hypothesis is in our hands. What we want to assume is our choice.
Sir,
In
so
that, what is the
what
value
was
of k that they want is their choice.
Okay, sir. Sir, but here you have mentioned by induction hypothesis, this can be now perfectly colored, but we haven't yet proved that if there are k lines, the quadrilateral can be perfectly colored.
Yes, that's an assumption that we have made.
Yes.
I understand your concern over there. You are saying we have only assumed, we haven't proved it.
Yes.
Right? So that is where this thing about cause and effect relationship come into play. This is the first domino, this is the nth domino, this is the kth domino. We are saying let's assume that the kth domino will fall. And in the induction step, we are saying if this kth domino falls, then the k plus 1th domino is also going to fall. We are going to show that in the induction step, which is what we are trying to do here. We are saying that if the induction hypothesis is true, then the induction step will also be true.
Okay, sir.
So if we are able to prove the induction step using induction hypothesis, we have established that cause and effect relationship. And because of that cause and effect relationship, you can, you can trace back and say that it went all the way back to 1 or the base case. Then you can trace it forward. You can say that it goes all the way up to n. Okay. But I don't expect everybody to get this 100%. So I just want to see a show of hands. Only if you have understood this 100%. You think that you have understood this argument 100%, do a show of hands. And please do not come under peer pressure and raise hands because your friend has raised hands, or majority have raised hands. I myself took a lot of time when I understood this for the first time. I could not digest it well. So it's completely all right if you are not clear with this. So we have about 40 participants, including me and these guys. Keep your hand raised. Keep your hand raised. And then we have the volunteers also. Okay. All right. So who would like to tell what's your, keep your hand raised. Okay. Anybody can tell where your concern is. If your hand is not raised, can you tell which part is not clear? Just unmute and speak.
Sir, theoretically we are proving that if the K lines are there, then also 2 colors will only be needed. And K plus 1 lines are there, then also 2 colors will only be needed. K will be given by the adversary, right?
Yes.
So now, sir, you are proving it by using diagram only, right? We cannot theoretically prove it in our argument.
So let's say that there is no diagram in the picture. Okay, we are just talking. You and I are, I am the one who is proving. You are the adversary.
Yes.
I ask you, Smrunil, give me a certain number for a K that you can think of. Give me a number, Smrunil.
10.
10. So I ask you, Smrunil, now you give me a plane with 11 lines. Can you do that?
Yes.
You do
Yes,
that.
sir.
You draw 11 lines and then you give it to me. I ask you, which one is the 11th line? You say that, the last one that I drew. You pick some line. Okay.
Yes.
Now I ask you to just, erase that line, but let the trace remain so that we know where to place it back. Okay.
Okay. Yes.
Now, even now we don't necessarily have to color it or draw it. This is just all the arguments that is happening in our head, just like what we are doing. Now you remove that K plus 1th line, which is erasing that line. Now you say, let us assume that it can be perfectly colored with 10 lines.
Okay.
Is this okay, Smrunil? It's just an assumption. Let's assume. Now what I will say is, look, if you have a plane with 1 line, do you agree that you can perfectly color it with 2 colors?
Yes, sir.
Yes. So induction hypothesis is over, base case is over. Now we come to induction step. In induction step, what I'm saying is, now you place your line back to where it was. Okay.
Yes, sir.
You place it back. Now I'm saying there are 2 parts that now exist. On one side, you do the coloring which was existing in the with the K lines thing.
Yes.
On the other side also, there must have been a coloring with K lines, but now you invert the color. You swap the color.
Okay, sir. Yes, sir. Understood.
See, I didn't draw, but we got it,
Yes,
right?
sir. Yes,
So
sir. Yes.
this comes after a bit of, or maybe after a lot of thinking.
Yes, sir.
Okay.
Excuse me,
Okay,
sir.
sir.
Yes, Kavi.
So, but what if the adversary won't agree that the swap won't make a perfect coloring?
Right. So the adversary has to be a perfectly logical person who should have this ability to argue logically and should understand this. Of course, if I go and tell this to my 6-year-old daughter, she she will have no clue what I'm talking about. So we are not talking about such kind of an adversary.
Okay, sir. So, like in okay.
So whoever is reading this proof, we are assuming that that person has the intellectual maturity and mathematical maturity to understand it.
Okay.
Okay. Shriya, can you tell me which part are you not convinced with, or you have a concern with?
Sir, actually, I was wondering that we've assumed that it is true, that we have assumed that it will be perfectly colored for K lines, and based on, and we have to prove the induction step. That way, we can
Right?
prove the induction hypothesis is true.
No, we are not proving the induction hypothesis. Again, I
Sir,
go back to the domino example. This is the first domino. This is the nth domino. Think about the argument that we are, just pick the argument. This is my kth domino. In induction step, I'm showing that K is causing K plus 1 to fall. Just like what we did here by induction hypothesis, I'm doing something that K can be perfectly colored, and I give some argument, blah, 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 invert these colors. Okay. And then I'm saying, look, now when the colors are inverted, you can do a perfect coloring. So to get that K plus 1, I have used the induction hypothesis on K. So when I do that, what I'm doing essentially is I am establishing a cause and effect relationship. That cause and effect relationship is going to continue further. It is going to happen with K plus 2, where K plus 1 is going to cause K plus 2, K plus 2 is going to cause K plus 3, and that will go all the way up to N. That cause and effect relationship. Now somebody will ask, but how do we know that K will definitely fall? We have only assumed, we have not proved it. You are saying, see, cause and effect means K was the cause for effect K plus 1 to fall. That means K should have been an effect of K minus 1 falling. And how did K minus 1 become the cause? Because it was an effect of K minus 2 falling. And that cause and effect will go back all the way to 1. And then somebody will say, but how do we know that K will fall? K will fall only if everything else before that has fallen. So that is where we say in base case that the first domino will fall, we push it and show.
demonstration.
Demonstration. So we demonstrate or we verify that the first one will fall, and then say, see, you saw that K and K plus 1, the cause and effect relationship. So because of that cause and effect relationship, 1 will cause 2, 2 will cause 3, 3 will cause 4, all the way up to K, and K causes K plus 1 to fall, which we have proved, and that continues. So induction step is giving that cause and effect relationship. And how do we know K will fall? Because the cause and effect relationship will go backward. How do we know that it will start at some point? We are showing that it works for base case. That's the argument. Now, to all of you who have raised hands and who have not raised hands, let me tell you, there will be problems where you feel that, oh yes, I got this, but then you will, oh no, I think I've missed it. So in your mind it will go back and forth. At some moments you will feel that yes, you are getting it. Some moments you may feel that you are not getting it, but that's all right. Okay, you will get there. You will all get there eventually, because this is not something that you can easily understand by just one reading or something of that sort. Okay, all right. So now you guys can lower your hands, and may I request you guys to turn on your videos, please. Okay, yes, right. How much time do I have, volunteers? About 40 minutes, right?
You have 40 minutes. Yeah.
40. Right. So I'm reminded of Subhashitam. I don't know if you have heard of something called Subhashitam. If you have learned a bit of Sanskrit, you would have heard of Subhashitam. So Subhashitam is a small, poem kind of thing which has a message. Okay. So there is one Subhashitam which goes something like this. That is Acharyat Padamadatte. Okay. Padam means 1/4. Acharyat Padamadatte. That means you learn from the Acharya, from the teacher. Whatever knowledge you get, 1/4 of that you learn from the teacher. If you have to understand something in 100%, don't take it in the literal sense that 25%, not 26 and 24. It's just a saying. So 24th you learn from the teacher. Acharyat Padamadatte. Padam Padam Shishya Swamedhaya. That means 1/4 with own thinking. You think upon it, you contemplate, you muddle on those thoughts, and then you get 25% more clarity. Okay. Padam Shishya Swamedhaya Padam Sabrahmacharibhya. That means with your peers, from your friends. Now, after discussions, you learn 25% more. And then Padam Kala Kramenacha. That means in due course of time, or as you grow more mature in that particular subject, you learn the last 25%. Okay, so this is very true for for all of things. In fact, this is something that I have experienced many times. I feel that I have understood 100% when I learn it from the teacher, but then when I think a little more, say, oh, I never thought about this when I was sitting in the class. Or maybe when I hear something from my friends, they say, wow, this never occurred to me. So I get more knowledge. And then as time passes, we feel that, oh, there was something more which I could never understand in all this. It needed some amount of time for me to get 100% of it. Okay. All right. So this is just a piece of advice in case you feel that, oh, I'm not getting this, not worry about that. Okay. All right. So let's work on another problem. Okay, let's get our hands dirty. So here's the problem. Maybe Shiva, Adi, and Kavin, can you lower your hand unless and until you have a pressing question to ask? All right. We'll prove one of the problems that many of you would have prove that sum of first n natural numbers is
n into n plus 1 by 2.
Yes, our favorite, right? N into n plus 1 by 2 using mathematical induction. Okay, now you know what the problem is, and you are asked to use a proof technique here. Okay, so I want you to try to attempt. I'll give you maybe something like 3 to 5 minutes to get started. So you write your problem, I'll ask you write the steps, I'll ask maybe some of you to read, and then we will work on it together if you need some help. Okay.
Sir,
Yes.
actually you had mentioned this problem during the video and I solved it at that time.
Yes, sir. The
Oh.
solution was also there, I
Yeah,
No, the solution wasn't there, I guess, but
Yes,
just the
sir.
problem was mentioned.
Was the solution there?
Sir, I think
No,
the
it
method.
wasn't there.
No, you started the solution and then you didn't
No,
complete it.
we then
All right.
you
Solution wasn't there.
All
Yeah,
right.
you
So
should
I'll give you
tend to
another.
the
I'll give you
steps
another
again.
problem. Another
No,
problem.
sir, the only thing you did was you added 1 to 100 and then you added like below that in the other
Yeah.
order, 100 to 1.
No, that was the derivation of the formula, I guess.
Yeah, Gauss did it. You had
Yeah.
explained in the last year.
That wasn't the proof actually.
Yeah, that wasn't the proof. So
That
maybe we
wasn't
can.
the proof.
Yeah,
but
we can
yeah.
continue, sir.
Yeah. Yes, Varun.
The question is same, right?
Yeah, question is same. Prove that sum of first and natural numbers.
Okay.
But can't we use the same thing as a proof?
Using mathematical
Yeah.
induction.
Oh, okay, yeah.
So still, can you give one more sum for those who have already solved that?
Yes.
Thank you.
Prove
This
that.
wasn't done using mathematical induction at that point, right?
Yeah, it wasn't. So those who finished this or those who finished this after this, you can check. Prove that sum of first n triangular numbers is anyone?
Is a square.
No,
Perfect.
it's n into n plus 1 into n plus 2, but
N plus 2 divided by
sorry, by 6, by 6.
6.
I'm sorry, sir, but I often get confused in the triangular numbers and such concepts. So can you just revise once what are triangular numbers?
Triangular
One-
numbers are
1
like
plus
this.
2. Yeah, 1 plus 2 plus 3. 1 plus 2 plus 3 plus 4.
Sir,
These
basically
are
the first
triangular
thing is
numbers.
triangular numbers, right? All the numbers are formed n into n plus 1 by 2 are triangular.
Exactly. All the numbers that you
Got
get,
it.
where n is a natural number, it's a triangle.
Yes, sir. Up to n, right?
Yes.
Okay.
So some of you may be thinking, I have no idea how do I even start, right? I mean, where do you start writing the proofs? So the best thing is to have that template in your mind and try to think what is the first thing that we are going to write. What is the first thing? Can somebody tell me what is that first line that you would, Shriya?
To prove that.
Shriya, say that again.
Sir, to prove what we have to prove or the claim.
Okay. And then in the proof part, what will you write first, Shriya?
So what we have to prove that the first sum of first n numbers is n.
I agreed. I'm saying after that, what do we write?
Proof
First
by
thing in the
mathematical
proof.
induction.
We have
Sir,
to do
method.
mathematical induction.
We
also.
will prove this using mathematical induction so that the reader is clear what he or she can expect in the proof, right? What is the next thing that we will write?
Induction hypothesis.
No.
We will do the
What
induction
we are
on
going
n.
to
We
take
will
as
do
n,
on
sir.
induction
do
on
the
n.
induction on.
We
Oh,
will
yeah,
do
the
the
base one is
induction
true.
on n. In this case,
Yeah,
n is
on
very
n.
clear where n is, a natural number, right? We will do induction on n. Then what will we write?
Induction hypothesis.
Induction
Induction
hypothesis,
Induction hypothesis.
right? And then base case, and then
Base
induction
case.
step. At least till base case, I expect you guys to go until base case if you have watched the videos, well enough.
Sir, there was one more, right? Like the sum of all angles of a triangle or something.
Yeah.
That's
Sum of
2n plus 180 or
and
something like that.
180 into something it was.
yeah. So all these generalizations, induction is a perfect tool to prove that.
Sir, I have completed the second question also. Can you write another question, sir?
Okay.
So can we try that? It says sum of all angles of an n-sided polygon is 180 times n minus 3.
Yes, you can try that. Let me
n minus 2, not n minus 3.
n minus 2. Yeah. N minus 3, I think, came from the diagonal formula.
Yeah.
All these get wired in our
n times of n minus 3 by 2 is the formula for diagonals.
So 180 times n minus 2 is for
Sum of all
the angles. Okay. All right. So let me write down this one. Okay. So I'll just call out somebody. Maybe you can help me build the induction hypothesis. Aryan, induction hypothesis for the first question. Aryan Agarwal. Aryan, are you saying something? Sorry, I'm not able to hear you. Some problem with your headset? Or you want to remove that and check? Until then, maybe Ishan Jain.
Yes, sir.
Yeah, can you give me the induction hypothesis, Ishan?
Yes, sir. I'm thinking about it.
Varun,
Yes, sir.
induction hypothesis.
Yes, sir. We can assume that the claim is true.
Assume that the claim is true
For that arbitrary, that particular claim.
for some
Yes, some arbitrary.
arbitrary but particular k. Okay, I can write one more sentence. In other words, 1 plus 2 plus 3 plus ... all the way up to k is going to be k times k plus 1 divided by 2.
So, sir, this sentence is necessary.
In other words, right? In other
Yeah.
words, this is for our benefit.
Oh, okay.
The reader may not want this, but for us to get a clarity, because this is a template. We are saying assume that the claim is true, but then maybe we are still stuck. Where do we have to start? So it is a good practice to write this. In other words, this is what. So we now say that okay, this is what we are saying. Now we go to base case. Base case. Gayatri, give me the base case.
Sorry, sir.
Base case for this problem.
Sir, we tried out for 0, sir. So, sir, 0 and 1.
Because it is for natural numbers. Because
Sir,
it is for right. So what should I write in base case?
Sir,
Gayatri?
yes, sir. Sir, 1 and 2. 1 and
Right.
2.
So
1
when
plus
n
1.
equals 1, when n equals 1, n into n plus 1 by 2 will be equal to 1 times 2 by 2, and that is 1. Right? And 1 is the sum of first one natural number, hence verified. Okay. Induction step. Smayan. You're still on mute, Smayan.
So I'm not sure how to expand it, but
so give us a goal. What do we want to prove in induction step?
We want to prove our induction hypothesis.
No. Induction hypothesis is k. Induction step is k plus 1. And to show that k causes k plus 1, cause and effect.
Then you take a case, like you take k and how? No, sir, I'm not
Sir, can
sure.
I try?
That's okay. That's okay, Smayan. That's okay. One thing, I just want to just talk to everybody because some of them are little quiet. Deepthi, can you help me with induction step? What should I prove in the induction step? Can you tell me that?
A goal will be to prove that n plus 1 upon 2 works on k plus 1, and
very good. Very
And
good.
to do that,
Mm-hmm.
we'll just solve it. I think I haven't solved it yet.
No. So that is a good start. So if I can write it this way, to prove that the claim is true for k plus 1. Maybe somebody will say, what does that mean? Claim is true for k plus 1. We say, in other words, now again, this is for our clarity. In other words, 1 plus 2 plus 3 plus ... all the way up to k plus 1 is equal to Smayan.
K into k plus 1
Are you
upon 2.
Smayan?
Yeah.
I am asking Smayan. Smayan, you are on mute, Smayan.
Well, it's the triangular number for k plus 1. Up to it's the k plus 1th triangular number.
How do we get the k plus 1 triangular number? See, kth triangular number is k times k plus 1 by 2.
Natural number only, right?
K plus 1 triangular number. Smayan, kth triangular number is k times k plus 1 by 2, right?
Yes.
So k plus 1 triangular number will be
K times k plus 1 by 2 all plus k plus 1.
no k plus 1 times k plus 2 divided by 2.
2 divided by 2.
Do you see why? Because k times k plus 1 divided by 2 is you take k, you take its successor, you multiply and you divide by 2. So for k plus 1, you will take k plus 1 and its successor, multiply them and divide by 2.
So k plus 1th natural number only, right?
Take Kavi. K plus 1th natural number is k plus 1.
Okay.
The 5th natural number is 5, no? 10th natural number is 10.
Yes.
We are asking what is 1 plus 2 plus 3 all the way up to 10. We are not proving that the 10th natural number is 10.
Okay.
Right. Okay. So this is what we need to prove. In other words, to prove that this is true. Okay. Ishan, is this clear, Ishan?
Yes, now, sir. Yes,
Okay, good.
Sorry, sir.
Hey, that's completely all right, guys. I mean, I'm just don't think that I'm judging you guys if I'm calling it. I just want to get different people speak and understand if I'm going at the right pace.
Sir, I didn't understand how k plus 1 times k plus 2 upon 2 came.
Okay, who's asking this question? Just one second.
Sir, Arham.
So Arham, what do you mean by k times k plus 1 by 2? Can I say that the number k multiplied by its successor divided by 2?
Yes, sir.
Right? So that is for 1 all the way up to k. So if you take 1 all the way up to k plus 1, that means we'll have to take k plus 1, multiply by its successor and divide by 2.
Okay, sir, got it.
Yeah, okay. Good. So like this, if anybody is stuck, just unmute and ask, okay?
Sir,
can you show the triangular number question once?
Sir, why did triangular number come into this question?
No. Somebody asked, can you give me an extra question?
No, but I'm not saying Smayan said something wrong, but when he was saying, he mentioned triangular number. I didn't.
Okay. So n times n plus 1 by 2 is okay. So let me get a step back. Have you heard of this mathematician Gauss? You remember I told Gauss story in the video, right? So 1 plus 2 plus 3 plus all the way up to 100, right? And you add 100 all the way back to 1. You remember that?
Yes.
So which will have 101, and you are adding 101 100 times. So 101 times 100 divided by 2. So what does this give? What are triangular numbers? Triangular numbers are numbers like 1, 3,
6,
6, and so on. Right?
Which is
So how do
basically
we
the
get?
sum.
It's the sum of first n natural numbers, you see?
Yes.
right? So how do you get the sum of first n natural numbers? This is my n, this is my n, this is my n plus 1, and this is my n. So n times n plus 1 divided by 2.
Okay. Oh, okay. Yeah.
Does that make sense?
Okay. Yes. Yes, sir. Yes. Okay. Yeah.
But triangular number formula is not n into n plus 1 into n plus 2 by 2. Sorry, by
Correct.
6.
Correct.
It's the sum of triangular numbers.
So this question is the sum of first n triangular numbers. That means we are not doing 1 plus 2 plus 3. We are doing 1 plus 3 plus 6 plus 10. We are saying is, if here n is 4, then 4 into 5 into 6 divided by 6, which is 20. But let me not jump into that problem. Let's finish this problem. And those who got that and those who are doing that is fine. Those who have a doubt in that, just don't worry about it right now. All right, so this is our goal. Let me ask, Kavi, are we done with our proof, Kavi?
Not yet, sir.
Sorry, say that again.
No, no, we didn't done with the proof.
We are not done. We have just said.
Yes, sir.
So 1 plus 2 plus all the way up to k plus 1 is k plus 1 times k plus 2 divided by 2. What is left to prove?
Sir, we need to prove that it is true for k plus 1 2, k plus 1 also.
Right. So this is only a statement. We are saying that this is our goal. We haven't proved anything. Very good. All right. Now what do we do?
True for k natural numbers.
Say that again.
So, but we assumed that it is true for k natural
We
numbers.
assumed that it is true for k, first k natural number. So we take this part. This is our assumption, right? This we can replace with k times k plus 1 by 2. So we say by the power of induction hypothesis, LHS, if I can call this as LHS and RHS. LHS equals k times k plus 1 divided by 2 plus k plus 1. Why? Because this is my induction hypothesis. And this is the right side of my induction hypothesis. So I am replacing the yellow part with k times k plus 1 divided by 2. Add k plus 1 to it. Is this okay with everybody? If anybody is not okay, just unmute and tell me.
So, sir, the yellow part, which is the induction hypothesis, we are replacing it with this formula, right?
No. In what we are supposed to prove, in that LHS, we say that there are two parts. One is this k plus 1 and what is left is induction hypothesis. So we are replacing the LHS in that whatever we get for free from induction hypothesis, we plug it in.
Okay, sir, I got it.
Yeah, plus k plus 1. Now it's your favorite game, right? You have some expressions, you add, subtract, blah, 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 and then we will get somewhere. Deekshant, what do you think we can do next, Deekshant?
Sir, this thing which you have written in yellow and green, LHS is equal to, we can, that same thing is equal to RHS, where k plus 1 is equal into k plus 2 upon 2. So we can simply equate it and we get both sides are equal.
Right. So you add them, then you get that, oh, this is nothing but k plus 1. Oh, this is nothing but k plus 2 divided by 2. Hey, that is our RHS, hence proved. Is this okay? See, we are taking these examples. If somebody is wondering why do we have to do all this, इसके लिए induction क्यों चाहिए? You can just do it using simple algebra. Why are we taking induction? We are using this as an example to get a better understanding of induction. Okay, how the structure is, how it follows, and all that. And you will see that because you have the power to invoke induction hypothesis, You are getting a big chunk of the problem for free. And think about the algebra that you need to deal with. Nothing. It is only, adding fractions. So induction, it kind of pulverizes the problem to a very small part. That's where we see the power of induction. Let's try another problem. The second one. Prove that the sum of first n triangular numbers is n times n plus 1 times n plus 2 divided by 2. Okay. So prove that 1 plus 3 plus 6 plus 10 plus blah 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 all the way up to the nth triangular number. What will be the nth triangular number? Anybody?
So that would be n plus 1 into n upon 2.
Right?
Because
that
that's
will
the
be
sum on it. Yeah.
correct. N into n plus 1 by 2. This prove that this addition is n times n plus 1 times n plus 2 divided by 2. Sorry, 6.
6.
This is what we need to prove. Now we start proof. Madan,
Sir,
can you
I
give me a start? Yes, question.
Let's start.
1 second. Question.
didn't get how that happened.
This thing.
Yes, sir.
Is
The
that
n into n plus 1 by 2. Yes, sir.
okay?
How do
So
we know
1
that
plus
it is
2 plus
the form?
3 plus 4. If you remember Gauss, this gives us 5 added 4 times divided by 2. Are you okay with this?
Yes, sir.
So this is the fourth triangular number. Are you okay with this, Dikshant?
Yes, sir.
Right. So this is 4 times 5 divided by 2, or 4 times 4 plus 1 divided by 2. So if this is what we do to get the fourth triangular number, how do we get
Oh,
the
yes,
nth
I get
triangular
it. Yes,
number?
sir. Yes, sir.
Yes.
Yes, sir. I got it out.
Thank you for asking that. I really appreciate people asking fundamental questions. Okay, so this is done. All right, Madan, tell me how do I start? Madan, are you here? Okay, volunteers just mark Madan absent. Shlok, how do I start?
Sir, let's assume the claim is true for some arbitrary.
Before that, see, when somebody comes to your house, okay, you don't say, okay, let's start business. You start with something. You start with a greeting. You welcome them with a smile, chai pani do, and then you start, right? So tell me, how do you start mathematical induction? Shlok. The first statement. The reader has no clue what he or she is going to read.
Oh, okay. Proved by mathematical induction.
We will prove this by mathematical induction. I hope everybody is writing these things down. Okay, we'll prove this by mathematically. Yes. Next step, Shlok.
Let's assume the claim is true for some arbitrary.
Nahi.
This induction is on n, where n is a triangular number.
Induction on n, where n is, a natural number. Shlok, this is okay.
Okay.
No, don't tell me okay, whatever you say. No, not like that. Are you getting?
Yeah.
Why we are okay? Good. Now let us come back to what you want to say. What did you want to say? Induction hypothesis,
Let's
right?
assume let's assume the claim is true for some arbitrary particular.
Claim is true for some arbitrary but particular what?
Number.
K.
Okay.
Okay.
Then
And
the
then what
base
do we do?
case.
No. In other words, because we want a clear picture what is our induction hypothesis. In other words.
Oh, so in other words, 1 plus 3 plus 6 plus 10 dot 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 plus n bracket n plus 1 comma.
Hey, where did n come from?
Sorry, plus k equals to
K plus 1 by 2, not plus k. This is the kth triangular number. Remember, we are talking about sum of first k triangular numbers.
Oh, okay.
Shlok, if you are not clear with any part, just let me know.
No, I assume that n plus n bracket n plus 1 upon 2 will be k. Like the whole thing
Will be the kth triangular number. Oh, that algebra will be very hard. It's better to assume it like this, okay?
Yeah,
This is equal to,
thing is k.
yeah, this is equal to
K bracket k plus 1 bracket k plus 2 upon 6.
Upon 6. All right, induction hypothesis over. Smayan, continue, base case.
Sir, can you scroll up one?
I can. Smayan, base case.
Yeah, so we can take anything, any case, like say 3.
No, base case has to be the
First
first
zero.
domino.
Okay,
The
so
first
0 or 1?
one. First
one.
domino, right?
So 1 is the triangular number. Which because n is 1 and 1 the triangular number starts with 1, so that is 1 into 1 plus 1 over 2, which is 2 over 2, which is correct. And k into k plus 1 into k plus 2 over 6 is 6 over 6, which is correct. It's 1 and it's equal to the triangular number.
So hence verified. Good. Induction step. Ishan, induction step.
Sir, I have a doubt.
Yes, go ahead.
Sir,
So
why
can
did
you
we,
take it up for a second?
Yes, Shreya.
sir, why did we do that 1 into 1 plus 1 by 2? Like, why did we prove that? Because we already know, right?
So what we are doing is when n equals 1, by writing this, we are saying that this is the first triangular number. See, n equals 1 is one thing and the first triangular number is 1 are two different things. Because n means the count and first triangular number means the sum of first. It's like saying when n equals 2, the first triangular number is 2 times 2 plus 1 divided by 2, which is 3. So when n equals 2, this is the second triangular number.
So where n equals to 2, k is equal to 3.
What is k? No.
The limit. K is the limit. Sorry. Yeah.
K is, so k is the number, kth triangular number, and k times k plus 1 is the value of the kth triangular number.
Yeah, okay. So k is basically the greater limit.
I think I have understood you correctly, but I'm not sure about greater limit, but never mind. If you are convinced, yeah. Ishan, give me induction step. Ishan, are you there? I can't hear you.
Sir, what is that IH?
IH is induction hypothesis.
Okay, fine.
So I'm asking induction step. What will be the induction step? Ishan? No, I can't hear you, Ishan. Again, that microphone thing, you want to just plug it out and plug it in. If it's I can't hear you again. No, maybe you may want to have it looked into. Who else? Amrita, induction step.
Sir, will it be to prove that the claim is true for the k plus 1th number?
Excellent. So that's a good start. See, you remember writing some answers in your exam that you have no clue how to start. It says, why did this battle of so and so happen? And you're saying you have no idea what the answer is. You're saying the battle of so and so happened because, at least you know to write until there, right? What will come after because is something that you will worry about later on. So you are saying, we don't know how to write the induction step as of now. So we say that to prove that the claim is true for k plus 1. Now, what does that mean?
Sir.
Yes, who is this?
Sir, it's convenient, sir. I think
yes.
The induction step is not more specific. Like to prove that claim holds true for summation of triangular numbers from 1 till k plus 1
Very good.
triangle number. It would be more
Very
specific.
Good. Very good. So we say in other words, because the first sentence does not make it clear, we are saying in other words, or you can directly start from this. But if you don't know how to arrive at this, you start with something. Assume that the claim is true for k plus 1. At least you know that you want to show for k plus 1. Then you say, what exactly is this? Say, in other words, 1 plus 3 plus 6 plus 10 plus ... all the way up to the k plus 1th triangular number is what? K times k plus 1 times k plus 2 divided by 2, right? Right? Amrita?
Sir, isn't it divided by 6?
Divided by 6. Happy?
Yes.
Okay. Is everybody okay with this?
Shouldn't it be k plus 1 into k plus 2 into k plus 3?
Yeah, exactly.
Srivatsan.
So I think you've written the summation for k, not k plus 1.
Thank you. Right. So this is bogus. This is not true. It is, what is this k times k plus 1 times k plus 2 divided by 6? It's the sum of first sum of first k triangular numbers, but we are talking about k plus 1th triangular number, which will be k plus 1 times k plus 2 times k plus 3 divided by 6, right? It starts from, if you look at it, it starts from k, and then k times k plus 1 times k plus 2. And here, if we are talking about the k plus 1th triangular number, it will start from k plus 1, go to k plus 2, then go to k plus 3, then divide by 6. We can also say that is 1 plus 3 plus 6 plus ... all the way up to k plus 1th triangular number is this, right? This is my k plus 1th triangular number, and we need to show that this is equal to k plus 3 divided by 6.
So we
now
just
if you look at it,
k times k plus 1 by 2 to k plus 1 times k plus 2 by 2.
Exactly.
And we figure out if it's equal to that. Again, algebra.
Yes. So here, in previous to this term is k times k plus 1 divided by 2, right? Because this is the kth triangular number and this is the k plus 1th triangular number. And we know by induction hypothesis. See, so far we may not know how to go ahead with the proof. So we are saying we need to prove this, we need to prove this, we need to prove this, and suddenly you remember, hey, 1 plus 3 plus all the way up to k times k plus 1 by 2 is nothing but
K
what our
times
induction
plus 1
hypothesis
times
says.
K plus 2 by
It
2.
is this part, right? So by induction hypothesis, LHS is K times K plus 1 times K plus 2 divided by 2 plus this thing here, K plus 1 times K plus 2 divided by 2. This is my LHS. Now we
Sir,
know what to
shouldn't it
do.
be k into k plus 1 by 6? The first denominator of the first is 6.
First term, sir, that denominator.
Oh, sorry. Thank you. This is 6, right? And then you add this. So you know, okay, I can multiply this by 3 by 3.
Yeah.
Right.
And we get 3 times K plus 1 times K plus.
This is common.
Common. We take that common and we get K plus 1 times K plus 2 whole bracket K plus 3. And so hence proof.
K plus 3. And this is
Yeah.
equal to RHS.
Yeah. Hence.
So one question, what exactly are we gaining by writing this by induction hypothesis? What are we getting from there? Of course, you get extra marks for doing that, but more than
The
that,
person understand what you are trying. Sir, we have proved that it is true. A k plus
We are
1, so we can
substituting
use
from
this.
different equations.
okay, one by one. Those of you who want to say, just do a raise hand. I'll call out your names. Shiva.
Sir, we have proved that it's true for k plus 1 if it follows for k. So we can use this mechanism backwards and forwards to prove that it's true for k and it's true for n.
Very good. So this establishes the cause and effect relationship between k and k plus 1.
Sir, but we can't say that we proved it for k, so it is acceptable for k plus 1. We just assumed it for k, and on the basis of that assumption, we're proving it for k plus 1, right?
So you are saying the ground is still shaky.
No, I was just saying in his statement, we can't say we proved it for k because the induction hypothesis is something we assumed. We didn't prove it.
Right.
Yeah.
Would somebody want to comment on that?
For n only, right?
Can I comment on?
Yes. Who is that? Urvi?
Yeah.
Yeah.
So k we are saying is any random number, and so it can be obviously greater than 0, assuming integer. So we are saying it can be any random number, and if k works, then k plus 1 works. Is only what we are saying right now. And what else we are doing is we are saying that it's true for 1. So what we are doing is let k equal 1, then it should be true for 2, right? Because 1 plus 1 is 2. And then if it's true for 2, then it should be true for 3, and so on. That's how we build the chain. K is not an actual number that you're considering, it's just like a random variable that we are taking.
So I think what Parul was trying to say, and Parul, correct me if I'm wrong, is that we haven't proved anything over here. I mean, by this statement, by induction hypothesis, by this coloring, that cause and effect relationship. Is that what you're saying? You're saying if it is true for induction hypothesis, then it is true for k plus 1. Is that what you said?
That was
right?
what I meant. Yes.
Yeah, right. So if it is true, but that itself is a cause and effect relationship.
Yeah.
Right. If it rains, the ground will be wet. Doesn't mean that it is raining right now. We are just showing a relationship.
Yes.
Right. Yeah. So this shows the cause and effect relationship, and when we trace it back, we show that the base case is true. So we know that, okay, base case, if it's true, the cause and effect will continue all the way up to k.
Yeah.
Then it goes up to k plus 1, and then all the way up to n.
Yeah, she was also right. Urvi was also.
Yeah. All right. So we'll have a help session, and I had put a message in the WhatsApp group that if you want me to touch upon something very specific in induction, then I would want you to just tell me so that I can try to focus on that. And I know that there will be examples or problems, or in your minds, at least in some of your minds, that how does this work and all those things. So you will get there, don't worry about it. Shriram says, everybody please stay back. All right, maybe there is an announcement that he needs to make. But I also want to just make one comment. In case you didn't go through the videos well, and by I mean, what do I mean by well, is not just watching the videos once. Okay, it is not watching the videos once, it's trying to understand what it is being said. So if you don't understand, that means you go over it again. You don't understand, you go over certain parts once again. Still you may not understand, but that's okay. So has there been enough efforts to go through the videos multiple times if you are new to this particular topic? Okay, and if you would have done that, then you would have got an added advantage, or you would have got an upper hand in terms of understanding this. All right, Shriram, you wanted to make some announcement or ask something?
I just wanted to take a pic with everybody and leave.
And nobody wants to show their face, Shriram. You can in the report you can put that Vinay Nair taught a lot of names. Wow, Shriram, you are such a powerful person. I never realized that you have this much power. So maybe we can just wait for maybe 15-20 seconds. I can see that some of them are combing their hair, putting some powder. Right. Okay. Let us know once we are done. And I also saw that some of you joined a little late. I was wondering what could be the reason. Some of you sent me a message that you had some connectivity issue. Maybe some of you forgot about the timing. You thought that it is not, it is 4:30 or 4. But I hope it is not because you didn't want to join on time, or you were attending something else, which is why you joined late. So make sure that you.
Or not.
Shriram, can they blink their eye?
I'll tell Cease after your announcement. So, yeah.
No, you can do that. So I thought I'll just ask this. So make sure that you guys join on time, unless until you are facing some network issue. Okay. Cheese.
Excuse me, sir.
Yes, Neil.
Sir, I might have I joined a little late and might have left in between a little, sir. I was traveling.